Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. In last class we started one problem. Half of the problem we completed in the previous class. Today also we are going to continue the same problem. So already we started with the problem. So actually we need to reduce the quadratic form to canonical form using orthogonal transformation. We started with the quadratic form. We just wrote the matrix form in step 1. Step 2, just find the characteristic equation, eigenvalue and eigenvector. So two eigenvectors we already done in the last class. We are going to continue the third eigenvector. Okay, so third eigenvalue is what? Lambda equal to 4. So in the diagonal we are going to get -1, -2, -1. The remaining elements are as it is. Okay, then check the first two rows which is different. That means we need to use cross multiplication method. Okay, so which is x1. Start with coefficient of x2, so which is -1, -2, 0, -1, -1, -1, -1, -2, and x1 by, just make the cross multiplication, 1, 0. Okay, x2 by 0 -1, x3 by 2 -1. Finally, we are going to get the element which is of the form 1 -1, 1. Okay, this is step number 2. Step number 3 is we need to make the clarification whether the, whether the eigenvectors are pairwise orthogonal, which means you have to verify the condition x1 transpose x2 equal to x1, x2, x3. Already we done the eigenvector. Okay, so x1 transpose means it's transpose. X1 we already know. Transpose means we need to make it as row vector. And x2, that is 1, 0, -1. It just make the multiplication. So 1 into 1, 1 plus 0 -1, which is 0, first case. And second case is x2 transpose x3. x2 transpose x2 we already know, that is column vector. Now we can make it as the row vector. And x3 is column vector. Just multiply 1 into first element into first element 1, second element into second element 0, third element into third element -1. So which is nothing but 0. And x3 transpose x1, x3 transpose row vector, x1 is column vector, first element into first 1, second element into second element -2, 1 into 1 is +1. So the answer is 0. Okay, so from this we are getting all three cases as 0. That means we can say the eigenvectors are pairwise orthogonal. Okay, the next step is we need to find the normalized eigenvector. So that means what? Each and every eigenvector we need to find the normalized form. Okay, for that we need to find L. L is nothing but you just make the square of each element, then find the sum. Finally we are going to take the root, which is called L. Okay, so 1 square, first element is 1 square, second element is 2 square, third element is 1 square. Okay, find the root, which is root 6. Then finally I want to divide each element by that L. Okay, which is 1 by root 6, 2 by root 6, 1 by root 6 for first eigenvector. In the similar way I want to find for the remaining two cases. So which is x2 equal to 1, 0, -1. Right, we get the form which is like 1 by root 2, 0, -1 by root 2. Third case is 1, -1, 1. You just find the square, 1 square -1 square plus 1 square. Then find the root, which is root 3. Then divide each element by that L, which is 1 by root 3 -1 by root 3, 1 by root 3. This is called normalized eigenvector. Step number 5 is we need to find the normalized model matrix, which means we need to collect all the normalized eigenvector as a column. For that, we are going to get the matrix which is of this form. 1 by root 6. First normalized eigenvector for x1. 1 by root 6, 2 by root 6, 1 by root 6. Second, 1 by root 2, 0, -1 by root 2. Third, 1 by root 3, -1 by root 3, 1 by root 3. So next thing is we need to verify whether n should be orthogonal, which means n transpose and n transpose n equal to I. Write n as it is. N transpose means you can make it as row as column. Okay, finally we get the matrix which is of this form. Then after multiplying these two matrices, we are going to get the matrix which is of the form 1, 0, 0, 0, 1, 0, 0, 0, 1. So that should be, which is nothing but I. So which is orthogonal. We are getting n transpose as I. That means we can say n is orthogonal. The next thing is we need to find D, which is n transpose an. N transpose we already know. A is given matrix. N is again n. Then finally multiply these three matrices. Finally we are going to get the eigenvalues which is in the diagonal. So 1, 3, 4, the remaining all elements should be 0. This is we already done in the diagonalization part. The same thing hereafter we are going to add one more step, that is called the canonical form. So the question is, we need to find the quadratic, we need to reduce the quadratic form to canonical form. So canonical form formula is y1, y2, y3, and write D matrix, and y is y1, y2, y3. It's a column matrix. After multiplying these three matrices, we are going to get y1 square, 3y2 square, 4y3 square. Okay, now we need to write the rank, index, signature. Rank is nothing but the number of non-zero eigenvalues. So totally we will have 1, 3, 4. We don't have any zero values here. So that means the rank is 3. Index, number of positive square terms which is present in the canonical form. So totally it is 3. We don't have any negative term here. And the signature is difference between the positive square term and negative square term. So negative square term, we don't have any negative square term. So that means the answer is 3. And nature, how we are going to find the nature of any canonical form? Just check all the eigenvalues. Okay, so all the eigenvalues are positive. That means we can say which is positive definite. The remaining thing we will see in the next class. Thank you.